Hi, today we will be learning about coterminal and reference angles, definition of radian measure of an angle, conversion from degrees to radians, and conversion from radians to degrees. We will also learn how to draw different types of angles which have been given to us in different formats. Our standards for our lesson is understand radian measure of an angle as the length of the arc on the unit circle subtended by the angle. Our second standard is explain how the unit circle in the coordinate plane enables the extension of trigonometric functions to all real numbers interpreted as radian measures of angles traversed counterclockwise around the unit circle. Our objective for today's lesson is students will be able to identify angles that are coterminal with the given angles. Students will also be able to determine the reference angles of the given angles, and we will learn how to convert from radians to degree measures and vice versa. Our essential questions of the day is, how can I think about an angle as the rotation of a ray around its endpoints? What is meant by the radian measure of an angle? What is the connection between the radian measure of an angle and the length of the arc on the unit circle the angle intercepts? What is mean to prove a trigonometric identity? Let's go over some of our key terms over here. First of all, I want you to pause the video and record all of these in your binder. You have to copy all of these notes in your binder. Coterminal angles. Coterminal angles, co means two, so we are talking about two angles that share the same initial side. Initial means the starting side, and the same terminal side of the angle of rotation. They are called what? They are called coterminal angles. So let's take an example. I'm drawing an angle over here. Okay, this is my y-axis. This is x-axis. I'm sorry, I'm not able to draw straight lines. Okay, let's see, and let's take an example. This is my initial side, because if I'm drawing any angle over here, I have to start from here. This is my initial side over here, and let's take it over here. So I'm assuming this is my 45-degree angle. Okay, so what happens is this side over here, this is called my what? Okay, let me pick the pen over here. There you go. Here you go. So this is my what? This is my initial side, because I drew my angle by using this side. That's my initial side, and the angle is stopped over here. This is called terminal side. Okay, now the definition over here it says coterminal. Co means two, so I'm talking about two angles over here. Now let's take an example. It says coterminal angles are the angles which share the same initial side and the same terminal side. Okay, same initial side and the same terminal side of the angles of rotation. So if I have to find another coterminal angle for this, coterminal angle will be what? It says share the same initial side, so I have to draw an angle which should end up over here, and the same terminal side. So this is my terminal side. So if I draw an angle over here, look at tick 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 tick. Here you go. And see, so the angle which I have drawn over here, this is my angle of rotation. Okay, so the angle which I am drawing over here, this angle from here until over here, this angle will be known as my coterminal angle for this. So now the next step comes is how we will find the value of this angle over here. Now you all know if I take one complete rotation over here, this is a 360 degree. So if I have to find this angle over here, so what I will do is from 360 degree, I will subtract my 45 over here. So my answer is what? 315 degree. So in this case, please pardon for my handwriting over here, the way, there you go. So this is my 315 degrees. What I did over here is I have, so this is my coterminal angle. I make sure you copy everything. Okay, next one is identity. What is an identity? An identity, an equation that is true for all values of the variable for which the expressions in the equations are defined. So this is when we'll go in depth about the identities, I will explain to you more over there. But what it says, an equation that is true for all values of the variables. I will take a simple example over. You all know about your Pythagorean theorem. Okay, a square plus b square equal to c square. You all know about this. In a right triangle, the sum of the squares of the two sides is equal to the square of the longest side, which is called hypotenuse. So if you are putting two values over here, which and it should be equal to this one. So let's take an example. If I'm taking three values like this, 3, 4 and 5, when I substitute these values over here in this, it should give me the, it should be, what do you call it, should be equal. So 3 square plus 4 square, yes, you know hypotenuse is the longest side. So when I will solve this, it's both the sides should be having the same answer. This is 9, this is 16 and 25. 9 plus 16 is 25 equal to 25. So as you can see over here, this is an example of identity. All right, so there's something over here. All right, let's talk about the initial side. As I explained earlier to you, initial side is what? It is the beginning side of the angle of rotation, and usually it is where? It is on the positive x-axis. So in this case, when I was explaining over here, so first which I drew over here, that's called initial side. So let's take another example. If I want to draw an angle, all right, so if I'm drawing an angle over here, first of all, let me draw my quadrants over here. This is my y-axis, this is my x-axis. So if I'm planning to draw an angle over here, I will need initial axis. Okay, initial side, the beginning side of the angle of rotation. So let's take, I can take it over here also, and I have drawn an angle over here. There you go. So you see this part over here, this is called what? This is called initial side, and this is called the terminal side. Negative angle, an angle in standard position is negative when the location of the terminal sides results from an clockwise rotation. Now the next vocabulary word which we heard just now is called standard position. What do you mean by standard position? Okay, so standard position is angle with its vertex at the origin. So let me erase this and draw one more angle over here just to explain this concept. All right, so now what I'm saying over here is, okay, so first of all the question comes is, what is standard position? An angle with its vertex. So vertex is, this point is your vertex. Now see, if I'm drawing an angle over here, so this dot over here, this is called vertex. Okay, what is this? This is a fixed point between the two rays. Okay, so if I see, this is my one ray over here, another one is over here, this point is called what? This point is called vertex. There are too many terms which are coming on the small page over here, but this is called vertex. What is vertex? Fixed point between the two rays, that's called vertex. Fixed end point, I should fixed end points. Okay, now what is standard position? An angle with its vertex or the origin is this point where your x and y both are 0. Okay, so let me zoom in a little bit if I can do that. Yeah, an angle with its vertex at the origin and its initial side along the positive x-axis, and its initial side is where? And its initial side is along the positive x-axis. These types of angles are supposed to be called what? Angles in standard position. So let's take an example. I have drawn an angle over here, and let's call this is 120 degree. What is this? 120 degree. So this angle is what called? This angle is called a standard position. Why? Because its initial side, it is where? On the positive x-axis, and its vertex is at the origin. So this type of position is called what? This type of position is called standard position. Okay, all right. So I'm trying to bring the whole page. Okay, let's go. Now next one over here is positive angle. An angle in the standard position. Again, standard position, angle whose vertex is at the origin and initial side is where? On the x-axis, positive x-axis. An angle is in standard position is positive when the location of the terminal sides results from the counterclockwise rotation. What it says? Results from a counterclockwise rotation. Now this is a new word. What is a counterclockwise rotation and what is a clockwise rotation? Now, so let's look over here. This is my clock. What I'm trying to draw is, I'm trying to draw a clock. It doesn't look like a clock, but we'll still pretend this is a clock. Okay, so in my clock, okay, Now what happens in the clock is, if you look over here, these what you call needles over here, or pins of this clock, or the clock hands, what they do, they move like this, tick 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 tick. You see, they will move in this way, tick 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 tick. So this is called what? This is called clockwise rotation. What is this? This is called clockwise rotation. So if in case you are confused, what you do, you think how the minutes and hours and in a clock they move, this is called clockwise rotation. Now if in case they are moving opposite way like this, they are moving in this direction, this is called what? This is called anti-clockwise rotation. Anti-clockwise rotation. Alright, so it says an angle in standard position is positive when the location of the terminal side results from counterclockwise. So now the next question which comes to you is, what was this example which I have drawn just now? Is it clockwise or counterclockwise? Now do keep in mind, clockwise means it should go like this. Counterclockwise means going this side. This means this is an example of counterclockwise. So this angle is positive 120. So if in case I would have drawn an angle like this going in this direction over here, then this means that will be my negative angle. Okay. Next is a definition of radian. The measure of the central angle of a circle subtended by an arc of equal length to the radius. I will explain this to you in the upcoming slide. Reference angle. What is a reference angle? The measure of the acute angle. Now next question which comes in, what's an acute angle? Angles though whose measurement is less than 90 degree, they are known as acute angle. Measure less than 90 degree are called acute angle. Make sure you copy the definitions. Acute angles. So an angle which is equal to 90 degree, that's called right angle, and angles which are measured than above 90 degree, they are called obtuse angle. Standard position, I already explained to you earlier what is standard position. In standard position, an angle is in standard position when the vertex is at the origin means 0 0, and the initial side lies on the positive x-axis. That was an example which I explained to you. Terminal side, that's the ending side of the angles of rotation. This is a terminal side over here. And unit circle, the word unit means 1. A unit with a radius of 1 and center is at the origin, that's called unit circle. Make sure you copy all of these notes in your binder. Everything. Copy these notes in your binder. Vertex. What is a vertex? As I explained on the previous slide, a vertex is the fixed end point. This is the fixed end points over here between the two rays. Okay. What is a ray? Ray is an arrow which goes, which is having one arrow over here. Okay. So initial side, that's a fixed ray. Initial side, that's a starting ray which don't change, it stays at one place. And terminal side, second ray rotated to form the terminal side. Next is a standard position, an angle which is standard vertex at the origin. Now keywords over here is vertex at the origin and its initial side, starting side along the positive x-axis is said to be in standard position. Now look over here. Initial side on the positive x-axis, that's your terminal side, and vertex is where? At the origin. Vertex at the origin is the initial side, terminal side. Now as you can see, this is going in a clockwise direction. This is what? A negative 120 degree angle. In this case, what was happening? This was going in a positive direction. Counterclockwise means positive. Clockwise, like our hands of the clock move, negative. Again, this is positive. So you can see the initial side over here, and this one, our axis is what you call vertex at the origin. Please make sure copy everything in your notes. Alright, our first example over here question says draw the given angle. Now before you draw any angles, you have to first of all learn about the quadrants. Okay, so if in a plane, if I'm drawing a vertical line and a horizontal line, it divides the plane into 4 different parts, and 4 parts are called quadrant. This is our first quadrant over here, this is our second quadrant over here, this is your third quadrant, and that's your fourth quadrant. Now in one quadrant, what is the measure of the angle over here? In one quadrant, this is your 90 degree. What is this? This is your 90 degree. Okay, 90 degree. What about this one? When you start from here over here, you go this part over here, this total is called what? 180 degree. Let me write over 180 degree. If we keep on going over here, this means I start from this side, I keep on going over here, this will be what? 90 plus 90 plus 90, this will change to what? 270 degree, and I keep on rotating until this point. The initial, this is called 360. So each of the quadrant is 90 90 90 degrees. All right, now to solve this problem over here, now this is not given to us in, you don't see any degree over here, it's just a pi. So what happens over here is the value of pi is what? It is your 180 degree. So just to make it easy, what I would advise you do is change this pi to 180 degree and use your calculator to solve this. So 5 times 180 divided by 6, it should give you the answer as what? It should give you the answer as 150 degree. So what we did over here is we changed our quotient, which was given in terms of pi, okay, and we have this 150 degree. So 5 pi over 6 is 150 degree. Now your job is to what? Your job is to draw angle over here. So let's start doing. Okay, so first of all, tell me where our 150 degree will be. Now always remember, you start over here. So this is your vertex and this is your initial side over here. This is your initial side. Okay, my line is not straight. There you go. This is my initial side over here. Now ask this question from yourself, 150 is between 90 and 180? Yes. If this is 90, you go, see, you start over here, you go, this is 90. But is this, no, this is 150. 150 will be where? Now you know, if you go from here until this place, this point will be what? 180. But since this is not 180, somewhere in the middle between 180 and 90, your angle will be. So now we might not be accurate, but what I can assume is somewhere over here. Let's see, let's stop over here. This is 150. So I will draw my terminal side over here. So this is my what? This is my 150 degree angle, or as per the question says, this is my 5 pi over 6. So this is how I drawn my angle over here. So this is my how to draw. Now always remember, this is a positive. This means we will go counterclockwise. Where we will go? We will go counterclockwise direction. Now let's look at number 2. This says theta is negative 220. Look at the negative sign. This means where you will go? You will go clockwise direction. Clockwise direction, because clockwise means think about the clock, how yours hands go over there. So let me first of all draw. This is my vertical line over here, y-axis, which and this scale, this is my x over here. There you go. Now always remember, let me change the color. We will start from here. Standard position. What is standard position? Angle whose vertex is at the origin and initial side is where? On the positive x-axis. So this is our angle in standard position over here. Here you go. Now you have to go which way? This direction, right to left. Okay, now you all know this is 90, this is 180, this is 270, and this is 360. Now even I go in this direction over here, this is what? 90. I need to go more because 220, I need to go over here. Is this what? This will be 180. Is it 180? No, it is more than 180. Now do keep in mind, see, I know 1 is 90, this means this is 90, this is 180, this will be 270 for me. This number is more less than 270. This means somewhere in the middle, somewhere over here I will stop. Now I might not be accurate, sometimes, but we can still use it. So this is my, I'm just trying to make it as neat as possible. Okay, bear with me because this is a new writing pad. I got it on Bluetooth, it works. So that's why it's going like that. All right, so this is my angle. What? This is my negative 220 degree. So that's my angle over here. So this is how we draw angles. So all right, so let's practice some. Okay, now let's go over this question over here. Question says, given each angle below, find a coterminal angle between 0 degree and 360 degree, or between 0 and 2 pi radians. Now in this case, what is given to us is, this question says theta is equal to 19 pi over 4. Now there is no degree symbol. Degree symbol means there should be a small dot over here. So they did not give us this dot. This means this angle is in what? This angle is given to us in radians. And we have to first off we have to find the coterminal angle between what, look at the condition, 0 and 360 degree or 0 and 2 pi radians. So first of all we need to know, let's try to plot this angle over here. First step will be plot this angle, and then we will find out what is the coterminal angle to this angle. Okay, so before I do this, what I will need is a, let me draw my okay, just bear with me with the straight line over here. I'm not able to draw the straight line, just trying my level best. All right, now first of all learn about this thing. This is my 0 degree. Okay, or what happens over here is, this is my 0 radian, because I have not gone anywhere. This is my 0 radian. There you go. This is my 0 radian over here. I have not even moved. I don't know why this is going on. Okay, so 0 degree and 0 radian, both of them are at the same place over here. Now after this, what happens is, if I will move from here, okay, and if I go rotate over, if my angle rotates over here till this place, this is called my pi radian. What this is called? This is called my pi radian. All right, so if in case I will move again from here over here, so now see, this part was pi, again I move one more pi radian. This is my what? This is my 2 pi radian. So this one whole complete rotation of 360 degree, that's my 2 pi radian. 2 pi radian and 0 degrees are same, and 360 degree they are same. Okay, now so if this is 0, this is my 0 radian, that's my pi. What is the half of this? Half of this is what? Pi over 2 radian. So this is pi over 2. What this will be? This will be 2 pi over 2. Now please be mindful, 2 pi over 2, when I cancel out, it's just the same thing, pi. Now if this is 2 pi over 2, I will keep on going, tick 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 tick, this pi, this part will be what? 3 pi over 2. If I keep on going, tick 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 tick, this is what? This is my 4 pi over 2. And 4 pi over 2 is this the same thing over here. So we something learn about the radians over here. So this is 0 radian, that's your pi by 2, this is 2 pi by 2, this is 3 pi by 2, this is yours 4 pi by 2. So now if it says pi by 4, what is the half of this? 0 and pi by 2, half is what? Half is yours, I will draw this over here, half is yours pi by 4. Okay, now I will tell you why. If this is pi by 4, what this will be? This will be 2 pi by 4. What is 2 pi by 4? You divide this, use your calculator, 2 pi by 4, you will end up with pi by 2 only. So this is 2 pi by 4. So this part over here, this will be what? Half of this. I'm just estimating half of this is what? 3 pi by 4. So this will be what? This will be my 4 pi by 4. Again, this is what? And I will erase all of these at a later on. This is my 5 pi over 4. So this is what? This is your 6 pi over 4. What this part will be? 7 pi over 4. And this will be 8 pi over 4. Now stop and think, 8 pi over 4, if you do this cancel out, it will end up with 2 pi. So it's just a different ways of writing this. 8 pi over 4, then this will be 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4, 14 pi over 4, 15 pi over 4, 16 pi over 4, 17 pi over 4, we are coming close to this number, 18 pi over 4 and 19 pi over 4. This is the angle which is my 19 pi over 4. That's my angle over here. So I will erase this and I'll write it over here. This is my 19 pi over 4. Okay, so now now what I will do is I will start from the beginning, so we'll know how many rotations we took to reach to this angle. So let me erase this over here and let me start from the beginning for you, so you can understand what I did over here. Now do keep in mind, we are not finding 19 pi over 4, we have to find the coterminal angle between 0 and 360 degree or 0 and 2 pi. So now you know by now that 2 pi and 360 degrees Okay, let me erase this and then we start. Okay, I'm getting some technical difficulties over here. Okay, so we just now learned, how to draw that 19 pi over 4, but this is not we are doing over here something. Now, do keep in mind our answer should be between these two numbers, 0 and 2 pi, 0 and 360 degree. Okay, now it might come over here, 19 pi over 4. This is bigger than 0 and 2 pi. Okay, so what you will do over here is just to find the coterminal angle, just make it easy. You will start subtracting 2 pi. Why I'm subtracting 2 pi? I want to bring it between 2 pi. This means I want to bring it below 360 degree. Okay, now let me make it easy let me explain by a different method to you. Okay, this is just to make it easy for you, change it to what? Change it to degree, so you will completely know what the measurement of this is. Pi is a 180 divided by 4, so this will give you the answer. Use your calculator for this. Okay, so you should end up with your answer something like 855 something. Let's go over here. This is your 2 times 2, this is my 90, that's my 45 over here. 45 times 94, sorry, 19. So this gives you, in other words, this is your 855 degrees. Now, is this 855 degree between these two? Okay, other you will find the coterminal angle, so but it should be coming between these two. This means 0 and 2 pi. So what you should do over here, just to bring it over here, subtract 2 pi from this. Okay, alright, so subtract 2 pi, it gives you what? You know how to subtract that. This is a pi over here. If I put 1 over here, multiply by 4, it will give me 19 pi over 4 minus 4 times 2 is 8 pi over 4. It become easy for us, like 11 pi over 4. Now again you can check 11 pi over 4, is it coming between 0 and 2? No, it's not coming. So what we will do is we will one more time subtract 2 pi from both the sides. Again I will do the same thing. This is my 1 over here. Now since I need 4, I need to multiply by 4 both the sides. So this is my 11 pi over 4 minus 4 times 2 is 8 pi over 4, which gives me what? It gives me 3 pi over 4. Now this 3 pi over 4, this is coming between these two numbers. So this is a coterminal angle for this. So my coterminal angle over here is what? My coterminal angle is 3 pi over 4. So bottom line, what you have to do is you have to subtract 2 pi or add 2 pi looking at the situation. So because you have to make one whole complete 360 degree round, as I mentioned to you earlier, to find the coterminal angle. So this is the answer for this problem over here. Let's do one more problem over here. Now if you look at this one, this is negative 445 degrees over here. So if I'm trying, let's first of all think what it will, let's try to draw this. If I draw this, now it's a negative, it should not go where it should go, in this direction, negative direction. So if I'm doing this, starts from here, it goes one whole is 360. Okay, this is negative 360, and negative 360, if I will take one more round from here, negative 360 plus this, what it will give me? Negative 450. So it should not be, it should be somewhere over here close to this number. So I'm estimating my answer over here. So my angle will be, this is my initial side over here. I started from here, and one more turn I took somewhere over here. So this is my negative 445 degree. Now in order for me to find the coterminal angle, what I need to do is I need to take one more complete turn over here, and I have to go a little bit this side over here. This is how I can put. Now what I did in this case is I have added one extra 360 over here to find the coterminal angle. So just add 360 over here. You don't have to show your work, you can just figure out on your own. So when you do this, you will end up with some answer over here. Use your calculator, give me, yes, you are right, your answer is negative 85 degree. Okay, awesome. So is this a correct answer? No, when I went back and looked up, my answer should be between 0 and 360 degree, but there's a negative 85. How we can make it positive? In order for you to make a positive, add one more 360 to this. So when you add one more 360 to this, you will end up with the answer which is positive, and which is between these two numbers, 0 and 360. So what is the answer? Your answer will be 275 degrees over here. So this is the answer over here. Okay, let's see one more question. Given each angle below, find the coterminal angle between 0 and 360. We will not do any of those things. This is 5 pi over 3. Just add 2 pi to this. Okay, so how you add 2 pi? Now you can use your addition of fraction, or if in case you are confused, Just put a 1 over here. How you can make this is 3? How we can make it 3? You need to multiply by 3, numerator and denominator. So negative 5 pi over 3 plus this is my 3 over here, that's my 6 pi. Now it become easy because the denominators are same. So negative 5 pi plus 6 pi will gives you what? Gives you pi over 3. Now is this pi over 3? Yes, this, if this is pi over 3 is what? 60 degree. No, sorry, this is your pi 180 or 60 degree. This is coming between these two numbers. So radian, and that's a coterminal angle for what? For this angle over here. Identify all angles that are coterminal angles with the given angle, then find what positive angle and negative angle. So what I will do is, just to find my positive coterminal angle, I will add 360 to this number, and to find negative coterminal angle, what I will do is I will subtract 360 from both the sides. So this is my positive coterminal angle over here, 45 plus 360 degree. Okay, so this gives me what? 405 degree. That's my positive coterminal angle over here. Now for negative coterminal angle, I will subtract 360 degree over here. I will end up with 315 degree. That's my negative coterminal angle for this question. Go ahead and copy the solution. Alright, same thing with this one over here. We have to find one positive and negative. So what I will do is, to find my positive coterminal angle, I will add 360 over here. To find my negative coterminal, what I will do, I will subtract 360 from both the sides. So once you do it, you will end up with the answer. So you can use your calculator to find the answer. 225 plus 360, this is your 585 degree. Over here you will subtract, it should be a negative answer for you over here. So 75 plus 60, what is the answer? 135 degree. So this is over here. Now this one is yours. You will do the same thing, add 360 and subtract 360. You will be able to find the answer. Go ahead and do this on your own.